Okay, so our learning goal for this video is we're going to look at more rational expressions, and our goal is to figure out what values are not included in the domain of the function. So let's start with that learning goal. Let's talk about what these things mean. There's some terms that we should know. Right? So when I talk about the domain of a function, the definition is a value that I'm allowed to plug into the function as an input value that will give me anything back as an output value. So let me give you an example of something that is not that does not have values in its domain, certain values in its domain. We talked about radical functions like y is equal to the square root of x. And so I'm saying there's certain x values, there's certain numbers that you're not allowed to plug in for x because you're not going to get anything back for y. So here's a simple example of that. If I say y is equal to the square root of -3, I'm saying -3 is a bad value. It's actually not in the domain, because if I go to a calculator and I try to simplify the square root of -3, okay, here's what it tells me. It says, I'm sorry, I can't give you a real number answer for that. There's an error message. It's saying this is not something that I can give you a number for. So we're saying that this is a value that is not in the domain. So I'm going to say this is bad. Right? So there's certain values that I'm just not allowed to plug in at all. Right? So when we're talking about rational expressions, we have the same problem. And here's the problem with rational expressions. With rational expressions, if I had a fraction, which that's what rational expressions are, and I said something like 3 divided by 0, right, and I go to my calculator and I ask it to check that out, let's do 3 divided by 0, okay, same problem happens. It's giving me an error message and says it can't divide by 0. Right, so that's our problem with fractions, is that the bottom of the fraction can never be 0. Right? The denominator is not allowed to be 0. I'm okay with something like this. 0 over 3 is fine. Right, so if I go to my calculator and switch that and say numerator 0, denominator 3, it's saying, yeah, I can give you something back. There's 0 for that. So this one's good, 0 in the numerator, 0 in the denominator, this one's bad. So what we're going to say is the domain of a rational function is everything that you want except for values that make the denominator 0. Okay? So we're going to take a look at some examples and see if we can figure out what those values are. Okay? So these are the same examples that we've already simplified. Right? But if I look at this first problem and I say, okay, what's going to make the denominator 0? I really am just focusing on this part of the problem. And I'm saying, let's pull that out, 5b minus 5, and I'd like to know when does this equal 0. Okay? And this is an equation that I can solve. If I add 5 to both sides, okay, and then I say, okay, well, that means that 5b is equal to 5, and then I divide both sides by 5, I find out that, in this case, b is equal to 1. Okay? So what I'm going to say is b equals 1. This value makes the bottom of the fraction equal 0. So I'm going to say this value is not a part of the domain. Okay? So the way we would write something like that is we would say all real numbers, right, or all numbers, okay, except 1, okay, which we can also write as b cannot be equal to 1. Right? So this would be a way of writing about the domain. We say anything you want, but b cannot be equal to 1. And I can do that for all of these problems. So I'm only going to do a few. So if I move down to this one, d squared plus d minus 6, the same idea applies. It doesn't matter what the numerator is. That can be 0. It can be whatever it wants to be, positive, negative. The bottom, though, which is d squared plus d minus 6, that cannot be equal to 0. So we're going to find out what values make it equal 0, and we're going to say don't put those into the function. So we can factor this. This factors into d plus 3 and d minus 2. Okay. And remember, after we factored, we set each of the factors equal to 0. Okay. And I can solve each of these factors. So in this one I get a -3, and out of this second one I get a +2. Okay. So these two values, -3, if I plug it in here and here and simplify all this, I get 0. Same thing for 2. Here's a simple example. If you want to see 2, I can say, well, 2 squared plus 2 minus 6. Well, 2 squared is 4. 4 plus 2 is 6. 6 minus 6, that made the whole bottom turn into 0. All right, so that's why I don't like 2, because that gives me a 0 in the denominator. So I'm going to say that my domain, okay, is all values except d cannot be equal to -3, d cannot be equal to +2. And I'd say my domain is everything, all d values except for -3 and 2. Okay? So for any of the other problems like this, I'm really just saying, let's find out what makes this 0. Okay, well that means 7e has to be equal to 4. E has to be equal to 4/7 the fraction. I'm saying that's the bad number. My domain is everything except when e cannot be equal to 4/7. Okay, so that's the idea of the domain, is that anything you want, plug in for that variable except what makes the denominator 0. So we're going to try to find out what makes the denominator 0, and say do not allow those values into the domain.